Good afternoon. I'm Raymond Graham, the director of the Platform Graphics team at Unity Software. The Platform Graphics team looks after all of our low-level graphics abstraction layers, as well as our shader compilation and authoring pipeline. Last year, Unity and Microsoft joined into a strategic partnership so that we could work more closely than ever before on exciting new technical advances and platform support. Ray tracing being one such example. So thank you for joining us today, and a big thank you to our friends at Microsoft for inviting us to talk about achieving real-time ray tracing on Xbox with Unity and DirectX 12. For the agenda today, I'm going to talk about the various DirectX 12 improvements we've made for all Windows platforms over the past year, and the future improvements that are still to come. After that, we'll dive into an intro to ray tracing Xbox using Unity. We'll go over the HDRP features, things to consider when thinking about performance for your ray tracing effects, and continued ray tracing improvements we're looking forward to make. Let's get right to it. We are working to continuously improve Unity's DirectX 12 backend, with the aim of accelerating rendering performance on Xbox and Windows platforms. Using DirectX 12, developers can harness the most advanced features provided by the engine, such as HDRP's cutting-edge ray tracing effects. Our goal is to promote DirectX 12 as the default graphics backend for Windows platforms in 2024, especially since it's been the only choice on Xbox platforms for many years now. But in order to get there, we have made some improvements for Unity 2022 LTS. We introduced a new memory manager that allows developers to commit to memory more resources than the available GPU memory allows. This greatly improves stability for large scenes. We've also made a large array of optimizations to the DirectX 12 renderer and have achieved meaningful CPU performance gains. As a result of these efforts, we have taken out the DirectX 12 backend out of experimental for Windows-based platforms and recommend it for use in your projects as of 2022.2. Because we share our DirectX 12 code as much as possible in the backend, these improvements also benefit Xbox platforms. So you may be wondering, what does this mean for you? And what kind of performance gains should you be expecting to see? So here you can see stats from our internal draw call performance test. You can see significant difference between the tests running on DirectX 11 versus DirectX 12. In draw call bound scenes, you should expect a significant CPU time difference, but really this is only the beginning. In Unity 2023.1, we landed further improvements to how we submit work to the GPU. With DirectX 12, we generate the commands for the GPU on multiple threads. We had the ability to do this in Unity for many years now, but the main difference here is the jobs can generate native command lists that can be submitted directly to the GPU. This gives us a significant speed up when compared to DirectX 11. But we weren't happy here with the amount of speed we were getting. We felt we'd still do more and get more out of it. So in 2023.1, we added a new threading mode called Split Graphics Jobs. Native jobs by their design cause the main thread to synchronize with the rendering thread, leading to stalls. So Split Graphics Jobs removes this limitation and allow the main thread, which is usually the bottleneck, to run fully uninterrupted. This leads to dramatic CPU performance gains you see in this chart. And here you can see another graph showing the performance difference between Split Graphics Jobs and native graphics jobs in a more representative scene. As I said earlier, we recommend that you use the DirectX 12 API. We want to hear your feedback, and we believe it's in a great place now to build your projects. And so this brings us to why we're even here. These improvements benefit all Windows-based platforms, and Unity's ray tracing implementation relies on DirectX 12 API. So let's dive into ray tracing on Xbox. Currently, ray tracing is only supported when using Unity's High Definition Rendering Pipeline, or HDRP. HDRP supports 5 different ray tracing effects on Xbox platforms. And here I'm going to show you a shipped game that uses these effects to create a beautiful and relaxing experience. Let's take a look at LEGO: A Builder's Journey from Lightbrick Studios. LEGO: A Builder's Journey launched in November 2021 for Xbox Series and One. At the original release, ray tracing was not available for Xbox and Unity, so the team have been waiting for it to become accessible. With the release of Unity 2022.2, ray tracing on Xbox is now possible. So in the beginning of March, the team released an update with support for ray tracing on Xbox Series X and S. And this is the version we will be looking at over the next few minutes. The update was built using Unity 2022.2 Beta 16 and a custom version of HDRP version 12. On Xbox Series X and S, the team uses ray tracing for ambient occlusion and reflections. Let's take a look at the settings and the performance of those two effects in a little more detail. Ray trace ambient occlusion, the team only uses a single sample per pixel, and then use the built-in denoising feature to eliminate most noise. The quality is much higher than the screen space version, and the results are more precise even at one sample per pixel, as you can see from the image on the screen. When used in combination with ray trace reflections, it costs around 5 to 7 FPS on most scenes to use ray traced ambient occlusion compared to the screen space version. And here are the settings the team used for ray trace ambient occlusion HDRP. Since this is small scale ambient occlusion, the ray length doesn't need to be that long, and the denoiser is enabled. Next, let's talk about ray trace reflections. These are much more costly to render than the screen space version, but the quality is also much higher. Even in Builder's Journey, where everything's on screen at a good angle at all times, there are still many artifacts of screen space reflections. So it really is worth it to use ray tracing for this. Depending on the scene in the game, the impact of enabling ray trace reflections is about 5 or 15 FPS. And you can see it just looks gorgeous. And here are the settings they used in HDRP. On Xbox Series X and S, the team used the Performance Mode option. In combination with built-in denoiser and detemper anti-aliasing, most noise is eliminated in their cases. Performance mode means we use one sample per ray, and we accelerate the rendering by minimizing the time spent in the ray trace shader in favor of time in the compute shader. Another thing that we do is we bin a ray per direction, in addition to reducing the resolution. If you want to know more about how we do this, definitely check out the talk from Anis at SIGGRAPH in 2019, leveraging real-time ray tracing to build a hybrid game engine. It's a great talk, and it goes into detailed explanation of how we get the most out of these effects. Since we're on the topic of performance mode, how does this all perform on Xbox Series X and S hardware? So here you see the game is running in 4K with Fidelity FX Super Resolution at 77% on Xbox Series X. When ray tracing is turned off, the frame rate is at a constant 60 FPS. With ray tracing enabled, the frame rate ranges between 35 and 55 FPS depending on the scene. For Lego Builder's Journey, that is still perfectly playable, as there aren't any quick reaction scenes. The game is mostly slow-paced and relaxing. It would be possible to hit 60 FPS if the team adjusted some other settings with ray tracing enabled, but the team didn't want to compromise the image quality. When it comes to performance, there are a few things that you have to keep in mind. Ray tracing is a resource-intensive process. The more ray tracing effects a project uses, the longer it takes the GPU to process the effects and render the frame. When targeting Xbox Series, you need to be selective about which effects to use and how much GPU time to allocate to them. For Xbox Series, we recommend some general rules when using these effects. One of them is sample counts. This refers to the number of rays per pixel that HDRP needs to evaluate an effect. Higher the sample count, the longer it takes to render the effect, and so therefore keep the sample count low. And then there's also performance mode. We recommend using performance mode for all effects on Xbox Series platforms. Both sample count and performance mode adjustments allow for better performance on Xbox Series hardware. We also have a HDRP example project called Xbox Small Office Ray Tracing. This project demonstrates HDRP's ray tracing features. This can be found on the Unity Xbox forum thread, introducing ray tracing for Xbox Series X and S. This project uses several effects as an example, but it is a good practice to evaluate how many of these effects you could use for your project. It's really great to finally see ray tracing for Xbox Series X and S in Unity. It has allowed our friends at Lightbrick Studio to deliver the best console version yet for LEGO's Builder's Journey. It's required very few code changes to get the new ray trace features working, even in their custom version of HDRP. I'm really excited about the work we have done and what we are landing in Unity 2023. We've laid down a solid foundation to build your projects and are continuing the work to deliver the best performance and the best visuals. I also would like to send a big shout out to all of our teams at Unity, the folks on the ray tracing team, HDRP, Xbox, and DirectX 12 teams. Also, special thanks to our friends at Lightbrick Studio for sharing with us their experience with ray tracing on Xbox. Thank you very much. Take care.